Hello, and welcome to AV Cyberactive. Modern on-premises and cloud network consist of many types of network devices, hosts, and services. Each of these services must be configured and monitored to ensure continued compliance with organizational policies and security policies. In this course, I'll explain the various types of security misconfigurations, including using default credentials, leaving unnecessary services running, and exposing services unnecessarily to the internet. Next, I'll cover the application container management, including how to pull containers from Docker Hub and then how to start them. Moving on, I'll explain how containers relate to security. I'll then harden security settings through group policy and manage software updates on premises and in the cloud. The next OWASP top 10 item is the security misconfiguration attack. This is a big topic. Really, what we're talking about here is making sure that every aspect of our network, our host running our web server stack, our web application, and all of that is configured in a secured manner. That's a tall order. It sounds like a lot, but really it is. And this means that we have to have proper design and planning right from the beginning instead of patchwork of band-aids after the fact, which ends up taking more time. Can cause problems which might mean that we are having fines imposed on us. We don't want a security breach. However, we have to be smart enough to put the time in at the beginning to take the steps to make sure that doesn't happen. So this means besides designing and planning, we also have to think about the configuration of our web application as it's being deployed. For example, we might be designing and planning, we have to think about the configuration of our web application as it's being deployed. Also, for example, we want to make sure that each item of them is configured from the same secured or hardened image to make sure that we have consistent baseline of security. And then of course there is the overall management of our IT solution of our web application. In the long term, what do? We should have centralized monitoring of some of the intrusion detection and or unified threat management system that will notify us when there are suspicion incident instead of us having to look through our logs, because time is definitely of the essence in determining web application breaches. The next no when it comes to the security misconfiguration is sticking with the default settings, whether you're talking about the IoT device or web server or anything else along those lines. Anybody can find out what default values are just by looking it up online, because the manuals for most of the items are out on the internet for routers, switches, server, hardware, IoT devices. All that stuff is published and publicly available. So that can be a problem in this context. So we don't want to stick with the default username password. We should consider whether or not we want universal plug and play UPnP enabled. Often this is enabled automatically on the things like network printers and home routers and home Wi-Fi routers. UPnP or universal plug and play is normally used to allow applications to configure port forwarding to allow access to internal applications through a firewall. But the problem is that the universal plug and play just assumes that the application is to be trusted, and if we have got a malicious application, then we've got a problem. It's like poking a hole through a firewall that really should not be allowed, and because we've got malware infections, essentially. The other thing to think about is if what we want to make sure that we do not use SSL. Having SSL enabled in a security misconfiguration because it is deprecated or discontinued at this point of time. SSL was the network security protocol that we used to use in secure websites over HTTPS along with PKI certificates on a server, but that's no longer the case. Neither is the transport layer security. Its successor security is the successor safe, or at least not the versions 1 or 1.1. We should really be using TLS version 1.2 or better as the newer versions come available. Now, do I set this within this PKI certificate when it's being issued or renewed? No, that is not where it is done. You determine if the SSL or TLS is being used or which version, both on the client side or on the web server settings, and also on the web server stack in its setting. For instance, if you are to configure III as a web server, you would go ahead and edit the registry to disable everything below TLS 1.2. On a Linux-based Apache server, you would go to the appropriate configuration file. The specific name and the location will slightly vary within the Linux distributions, but also you go through the appropriate config file where you can disable or enable components of the web application Apache server, including security protocols it will not use. The default passwords are absolutely notorious for being an easy way to break into the system, and now this is not a secret anymore. This is freely available on the internet. Notice the overwhelming occurrences of the username of password with a password or being admin and the password being password. Now let's look at an example. We're going to see a lot of the same stuff here. Admin, password root, alpine, just variations of those type of things. And let's not forget the most common passwords like 12345 ABC123, or putting together 2 and 2 together. If you have a sense of some account you want to break into, look at their children's names, their pet names, their favorite car, their favorite movie, their favorite sport. Probably some form of that is being used as their password. But really, you're here focusing on default configuration being security misconfiguration. But one could argue that if a web server admin uses their pet name, something like that, so Snowball is a password that is also a security misconfiguration. So because really you wouldn't want to take much time for a determined attacker to figure that out, especially if the admin posts picture of him and her with their rabbit on social media. Some missing patches is another big problem of this for the security misconfiguration. Imagine that you've got many different type of devices on the network, smartphones, printers, and even smart vehicles that we track might have a fleet of vehicles for corporate use, servers and smartwatches, routers, medical devices, and so on. We might have to make sure that the firmware patches are applied on all those in timely fashion, as well as, of course, the software patches. That could be monumental task. When you have thousands of devices on the network, it means that you have to have a way to know which devices are on the network, and inventory, in other words, is up to date. And then you need to know that they are configured in what versions of patches they are before you can know what they are missing and push it out to them. So this can be a monumental task. Some solutions in the enterprise will require a software agent to be installed on each and every device to get the full capabilities of the inventory process, and then there's not being able to important updates. As a security professional, you need to be subscribing to all the applicable websites and RSS feeds where the case is in case of security related and what you're responsible for. One of the reasons that the Equifax hack of 2017 succeeded was because the attackers were able to determine that a known fault with the Apache certs, that's the Java web application, web development environment, and for a web server that was missing an update. So there was a known exploit that was missing update, and this was taken advantage by the attackers, and they were able to remain undetected for more than 70 days in Equifax network, all because a single update was not applied. Now, I'm certainly not pointing the finger. It can be a very difficult task to track the versions of updates for a single device on the network, but at the same time, that's why the IT security is the thing. That's why people have jobs related solely on it. Another security misconfiguration is not requiring the use of HTTPS. So we really are talking about HTTPS, strictly transport security policy, or HSTS. Well, what is that? Now, what this means is that the software developers can configure web applications so that the server will inform the client via HTTP header. Response header, of course, the original HTTP request is in the client connecting the web server, but the response times and say, hey, you, HTTPS is required. We are not using HTTP. So what does this? It forces a redirect from HTTP to HTTPS using HTTP 301 permanent redirect message. But remember, in order for us to work, HTTPS has to be configured correctly on the server side. So we need to have a valid PKI certificate with a HTTP binding message, which normally listens to TCP port 443 server side. So there is certainly much more about security misconfiguration that we really need to reconsider in a real life production environment. To configure out where you should focus your energy, you need to look at exactly what is being used by your web application and then follow it up on the threat feeds related to those components. Application containers are all the rage for software developers, even in some cases for the admins. But what exactly is it and why is it all the rage? Well, an application container you can think of as being a self-contained application, or it could be just one component of a larger application. For example, a large application might have some specialized printing functionality, and maybe that printing functionality runs its own components within its own application container. But either way, we are talking about independent container containing applications that is portable. You can move them between different hosts and support running containers. You can modify one container independently of the other. So if you have two containers, one's dealing primarily with printing functions of a larger application, and the second container is dealing with file uploads. If I need to make changes or tests, or if I need to apply patches to a file upload portion, that it's in its own container, so I can bring that container down to do what I need to do for affecting other parts of the application, so it lends itself to the application modularity. So pictured in the diagram, two on the right bottom side have the host operating system, whether it is running Windows or Linux or Unix variant. Now above that, we can have an engine that supports running containers such as Docker engine. It runs Docker containers. Now above that, of course, we might have binaries and libraries that are called upon by the application container shown on the left. We have application containers shown here, labeled as all the way though to, and have application AG, and where we have its own application, or there might be an application component that work together as a larger application. Now we don't know what by looking at this diagram, but the key here is those containers run on top of the binaries and libraries, Docker engine, and ultimately the operating system. So if you want to think about it, the application container does not certain an operating system like a virtual machine does. And you know what? That's one of the reasons why application containers starts up so quickly. The underlying operating system is already running to the operating system. A containerized application just looks like another running process in an operating system environment. So that's one of the reasons why the software developers just love these. It's okay. So it's so quick and it's easy to get another container image up and running on the container. Make changes, bring it down, bring it up again. Very quick, very easy to work with and manageable, as opposed to doing same type of things which bulky looking virtual machines that contain an entire operating system. Now, there are a number of commands related to Docker when it comes to container management. The first example here is the Docker run. Now, what you do is specify the container image you want to run, and when it is running, it's just colon container doc run. -D means run in the background. -P means I want to map port. Specifically, in this case, I want to map port 80 on the host where I'm mapping in the command where I got the Docker engine running. I want to map a port 80 and port number 80 in the container, and of course I will give it a name on the container image, so I want to load up. Now that command will only succeed correctly if the containerized application actually has the web application stack server within it. Now every container does, certainly not all. It might just contain other application binaries or config files. We can type Docker images and get the list of container images available on the machine where we are currently running the Docker command. You can pull down the images from the repositories on the internet, even free repositories like the Docker Hub, where there is a collection of public and private container images. The Docker PS will show you the containers currently running. The Docker stop will allow you to stop the container, and then there is a notion of tagging and remaining Docker container image. Now, you would want to do that if you knew that you wanted to push the container image up to a centralized container repository. When you rename it, the prefix of the new name is the name of the container repository you want to push it up, which is in this case acr172.azure.cr.io. So Docker tag. You have to give it a current container image, the prefix for the repository, and then optionally the new container name, such as the new container. Here is in Linux, we have some screenshots of running Docker images prefix with the su command because it is elevated command, and here we are seeing that it returns that there are two container images on the local host. One is called caddy, another one is called alpine. Down below, we actually have the run container from an image using, in this case, su Docker run. And there is the dash D and the dash P we saw in the other example, mapping port 80 on the host. The port 80 on the container, if we know it's running the web server stack, and the name of the image we want to load its container from call the caddy, after which it will open up and will be up and running, and in this case presumably listening to the port 80 and local port IP address of the name. Now in the cloud there are also containers based on the solutions such as Microsoft Azure, which we can create what's called the Azure Container Registry, ACR, and that this is a centralized cloud repository of container images, and images can be pulled down to other locations like the Docker Hub. You can tweak and modify and customize them and push them into their own as your container registry, as your container instances, otherwise called ACI, and simply put a managed cloud service where you can provision a container very quickly and it runs in the cloud. You don't have to worry about underlying virtual machine and make sure that the Docker software is installed. It's all taken care of now. Image sources that you can specify to load as your container instances from include a quick start list of images, the Azure container repository. If you've got some customized container images, you can load them up from there and then get them up and running. Or you can point to a Docker or many other container image repository or registry in the internet. The other aspect of application containerization in a clustering and parallel processing, and that's where the Kubernetes services come in. Kubernetes really is a cluster of container nodes, in other words, a virtual machine that run containerized application. It's designed for large scale processing. Parallel processing means we can process at the same time. We have multiple nodes that can process, for example, extra large sets of data sets. Also, Kubernetes is an orchestration service where we can manage the entire fleet of cluster nodes as one unit, and also service discovery of what's happening in terms of containers are available or nodes available in containers. Now, what that does, this have to do with the old OWASP top 10. These days there are many web applications that run in an application container, and so if we need to have some knowledge on this, because if, for example, we run a vulnerability scan on a host and see that it's listening on the port 80 and 443, when we go to the host, if we don't see on that host that there is a web server, we might wonder what's going on, when really it might be a container running in the background or on that host is causing us to see the port 80 or 443. So there is no question that to harden a web application, we absolutely must have a solid knowledge of application containerization. Before you can work with application containers, which might be used by web application, you need a host that runs an engine that supports containers. In this case, I'm going to use the Docker engine on Linux, although you can also run it on Windows. So here in Linux, I'm going to start by running su2 apt command installed Docker.io, the Docker.io package. Now at this point I found out that in one of the Linux repositories online, and it's pulling it down from this machine. So if you want to make sure I have the Docker engine installed, we are going to verify that, but then we are going to have to make sure that the Docker service is up and running. So right away I'm going to run su do docker enter. Well, it's good news, because if I go back to the output, is just simply saying that, hey, there's the next level of commands you can run after Docker. There's a hierarchy of commands that we use for Docker. So I'm going to clear the screen. I'm going to run sudo service docker start. I want to start the Docker service. It has to be running to run containers, and I'm going to use the up arrow to bring up the previous command. But I'm going to start the status over here. Let's just verify it's up and running, and it looks like the Docker application container engine indeed is active and running. No errors. It doesn't look like an excellent queue for to quick. All is good. Okay. Now what I do is, well, you work with containers, but how do I get a container where you can build your own using what's called a Docker compose file? But what you could also do is run Docker pull, and you could specify the name of the image like Alpine. Well, if you just say Docker pull, if you don't mention specify repository, then it assumes that you want to pull down from a Docker hub online where you can search the container images and discover, for example, is one called Alpine and some more. let's go and take a look at the Docker Hub for a second. So I'm at the dockerhub.com, and I can create an account and sign in by simply searching it for the containers. Here it says, hey, you can search for great content like MySQL. Oh, that could be cool. Having a container with MySQL already up and running and ready to go, I can just start to work with the database. Yeah, sure, you can do that. There are all kind of MySQL command containers that you can even see over names over here. So let's say you wanted a PHP admin and there's a name in the container. You could also say that pull PHP my admin, and one of that we are going to do here, say Alpine. There's just thousands of them here. It's a minimal Docker image based on Alpine Linux. With a complete package index, only 5 megabytes in size. That's interesting. Now, this is how we can start to learn from what the container images are out there and what we can do to bring this container image and then tweak it to our liking, publish it to a repository, potentially just to keep it in your local machine. And then you could fire up your new containers from that customized image. You would be starting at where all the stuff that you like and you have done. Let's say for MySQL database or extra tools within that container, they're already here. You know what it's like? It's kind of like making an operating system image. If you're going to deploy a Windows 10 on a couple of hundreds of laptops and the laptops are similar, then what you might do is build a golden image and then tweak it to or one of them and then just deploy the image on the rest of the laptops. That's kind of what it's like with container image, from what you can launch with many instances of containers from that same image. Anyway, let's go back to Linux and then let's pull the Alpine container image. So that's pretty easy right here. We're going to run our docker alpine command. I'm just going to press enter unless you tell it the version is bringing down the latest one. So okay, if you already have it downloaded, then it will be even quicker. So I'm going to clear the screen. I'm going to run su do docker images. Wow, I got a bunch of them carry over here, Alpine, Ubuntu, XXE lab, and so on. So if you want to run Alpine container because the image is there, then you can do su docker run, let's say dash interactive with a terminal in it, in other words Alpine, and just like that it's up and running. I have a separate prompt, and when I type ls, this is not happening for the underlying Linux OS. This is actually showing me what's in the file system within that Alpine Linux container. This is its own file system. I could tweak it, I can install stuff like install software, I can do whatever I want. That's the point of application container. It's a boundary in which you do application stuff. You can run a web server, you can run tools, you could do anything. And of course, to get out of here, I could just type exit, I clear the screen, and if I run docker ps, then I'll see that I don't have any containers running because I just exited out of that. So no containers are up and running. So in the same way, when you ran su docker images, we saw that, for example, there was one called Caddy. This is a small lightweight web server, basically very tiny, very quick. Again, way quicker than having a virtual machine that you fire up just to load a web server. That's just a waste of resources in this day and age. If you're going to be working with a lot of application containers, especially in the cloud computing environment, and if you're using Microsoft Azure, your cloud provider, then you're going to be interested in knowing about Azure Cloud Registries, which is really a centralized repository for your own container images that you have only available to whoever you deem to have access to this centralized repository. So to get started here in the Azure portal, I want to create an Azure container registry in the ACR. So to begin the process, in the upper left, I'm going to go ahead and click create a resource, and I'm going to search for container registry, and then I'll choose container registry, and then I click create. So I'm going to have to specify a resource group here in the Azure cloud that I want this to be deployed into. So let's say project X resource group. Remember, it's just a logical way to organize related cloud resources, much like you could create a subdirectory on a hard disk to organize related files. What you do want to call this registry, so how about a CRE project S, and it's going to verify that name is unique. We have green check mark on the right hand side of the field, so that's good. And it's also going to be automatically appended to the .azure CR for Azure Container Registry .io DNS suffix. So I'll deploy this, so let's say in Canada East, and if I go to the next networking, because I'm not going to premium SKU, I don't have a lot of additional options. So I'm going to go ahead and click review and create. I'll create the container registry. Now this won't take long, but there's more work. We have just basically created the skeletal infrastructure. We then have to be able to populate it with container images, and we are going to do that to here. It's all good fun. So it says your deployment is complete. All right, let's go and click on the resource, and now in our container registry, first thing I'll do here is to scroll down on the left, click access keys. Here we have a reference of the registry and the name of the login server, which is actually the DNS name and that default suffix at the end of the name, but I'm going to go ahead and enable admin user. So then the username becomes the container registry and not the DNS name, just common name. And then we have two passwords, so we could use either one of them, and really the same. The reason we have two is that, for some security perspective, you should periodically regenerate or rotate keys, change them, so one can remain static for time being while the other can rotate, and eventually you can go back and rotate the first one. Now any references to the old one will no longer be valid if you generate it, but anyways, for a security perspective, it's not a bad idea. Okay, so now what I do, well, luckily for us, we can look at a quick start here. On the left, it tells us exactly what to type in. It says before you really work on the Azure Container Registry, you should install the Docker as well. We already did that, so I have that running on Linux on my premises system, and it talks about running a hello world container. Well, I've already run containers, so I don't need to do that, but this is getting interesting in this step because now I can log into my container registry. I'm going to do this from on-prem Linux installation that has internet access, where I've installed Docker. So I would run docker login and just give it some name over here in my container registry. That almost sounds too easy. Not really that easy. I'm going to copy that and run it on Linux. Okay, they're on my premises Linux system where I'm already running Docker, and I can verify that, let's say, just by typing in Docker, it knows that what I'm talking about. It knows what the command is, so I'm going to be installed here. I'm going to run su, so I'm going to just go ahead and paste in what I copied from the Azure portal, which is Docker command along with the full name DNS on my Docker command container registry. So I'll press enter. I want a surname, and remember, this is just the common name, so in other words, ACR East Project X. Okay, and asking for the password. Well, remember, there are two passwords for keys. Whatever you will want to call them, I can use either one of them, so I need access to go back to the portal to copy that back here in the portal, and I'm going to go to access. Doesn't matter which one I copy. How about I copy the first one onto the clipboard? So I'm going to paste that into my Linux host, and after I press enter, it says login succeeded. So I have successfully authenticated into my Azure Container Registry. Now the next thing I'm going to do is I'm going to run the Docker images command. I have a number of images that are available locally, including, for example, Alpine. Now what I'm going to do is I want to make sure I can push the Alpine lightweight Linux application container into my Azure Container Registry. Currently I have it available here, so I could launch it if I wanted to with the Docker run. Let's say interactively terminal, and it's called Alpine. And because I asked for an interactive terminal, that's what I got. I'm going and I'm in a Linux command prompt here with only my container, not my local Linux file system. So I could make changes, add files, install packages, or do whatever it is I want to do, and tweak and customize the container images. And when I'm finished, exit, and it's no longer running, I can verify with the su docker ps. So what I'm going to do is I have to rename that local container image from Alpine to something that looks like this. I've got to have my Azure Container Registry DNS name followed by a slash name, and I want of the container image once it is pushed to that container registry. So the way that we rename a container image is using the docker tag command that like remaining. So what I want to do is I want to rename a local container image called Alpine to do my DNS name and for my Azure Container Registry, followed by / and whatever I want to call it up there. So let's say my Alpine, I'll press enter. So if I take a look at the local image Docker images over here, sure enough, that's Alpine with my prefix name and Azure Container Registry. That's important because when you're going to push it up to the registry using docker push command, you know how does it know the name of the registry? Well, because it's a part of the nomenclature. Right here at the beginning, it's the prefix. That's the name of the registry, the DNS name, and I'm pushing this up to, and it's called my Alpine. So I have to have tagged it or renamed it locally first before that one will succeed. So let's go ahead and push it up the Azure Container Registry. Let's see what we get. Okay. That didn't take very long, so we will still have to be available locally. It's not like it removed it. We could verify with the SU Docker images, but why don't we go back to the Azure portal to see if my Alpine container image exists in our Azure container registry? So here in the portal, I'm still in the properties of my container registry, but let's check our work. I'm going to scroll down on the left and I'll click repositories, and sure enough, what do I see as the Alpine? If I click on it, I have some details about it. We have got one version of it. You can have multiple versions. It's the latest revision, so that's great thing about this is now other Docker enthusiasts or software developers, whatever the case might be, can pull the latest version of the my Alpine customized container image from this repository to work on their machines. The way they would do that would be doing something like this. Now, first of all, they would do what we initially, they would have to run Docker login and they have to authenticate, and we have already authenticated, so we are logged in, of course. So then what they would do is run as you do Docker pull from the repository, which is ACRE project X dot Azure ACR IO. They would pull down my Alpine. If they want the latest version, they can follow that with the colon and the version, in this case latest, and what they would be doing is bringing that down to the local machine where they could work on it. So if I clear the screen and run su docker images, then indeed we are going to have the latest version of my Alpine container image from our repository. Alright then, so at this point we've taken a look at how to manage Docker containers on-prem, how to make Azure containers registry and populate them with container images. Finally, let's take a look at actually how to deploy a container in the Azure cloud. Now this means we are going to be using it as a managed service, so I can, so I don't have a lot to worry about myself about setting up an underlying virtual machine on which the container will run and installing the Docker engine and tweaking it. I don't have to do any of that. That's a great thing about cloud computing. That stuff is going to be provisioned for me. I just focus on the container. How do we do this? It sounds great. Here in the portal, I'm going to click create on resource on the upper left, and I can search for what I want to deploy, or I even have a containers category over here on the left, and on the right I'll just choose container instances. That's really what I'm interested in here, so I'll deploy this in a resource group in the cloud and organized related cloud resources, and this container I'm going to call it my custom cloud container 1. Okay, and I'm going to deploy that in the Canada East. Now I can specify the multitude of different resources from which I can choose container images and load up to a running container, so it can be quick start images. And down here we have some containers for hello world containers that will run Linux, such as using Nginx and running on Windows, that kind of thing. However, I could also choose Docker Hub or other registry. Now with the Docker Hub, there are both public and private images that you can pull down. So if I go to the hub.docker.com in my web browser, I don't even need to sign in if I'm just going to general public container images. So maybe I could just search for LAMP, Linux, Apache, MySQL, PHP, or Python, and if I've got a bunch of container images saying already that I have that stuff ready to go, I can simply download and go at this point of time to see via its URL. So we can see the URL here with the docker pull command shows the container image that I can choose to pull down. However, that's not what I want to do in this instance, and I back in the portal here, I'm going to choose the third option for the image source, Azure Container Registry, which I'm just a cloud repository for custom images you can push up. I've already done that. I've got a registry called ACR here and container registry E project X, and within it I've also got only the custom image called my Alpine and only one version, that's the latest version. Okay, well, that's fine. That is what I want. Now, depending on the container image that's going to fire up, as container will determine how much horsepower you need. You might think you need, such as whether it's running on the web server stack or maybe in the Java serverlet engine or anything like that. So I can click change here in the size and the number of CPU cores with the amount of RAM and for the underlying virtual machine that can be supporting for this cloud. That's about as much I can go in related to the underlying cloud virtual machine. I do not need to change that in this case. I'm going to leave it here. I'll click next on the networking. So if I leave this as a public container type, it tells me it'll create public IP for my container instance. Well, if it's the type of thing that you should be publicly accessible, like the public web application, that's would be okay if that's the case. And down below, if there are any port numbers I want to map within the container, I can specify them from here, and then that depends on the container. Some containers might have a web server stack and some don't. I'll click on the next advance, and there's nothing I'm going to change here for the tags. I'm going to add the taglines meta, and once it passes the validation, it will create my container image in the cloud. So let's go ahead and click create and give me a minute to launch it. After a moment, the deployment is complete. So let's just go from here. Let's open our navigator on the left. Let's go to the resources because I'm going to look for my Azure Container Registry ACR. Here it is. I'm going to click on to it, open it up, scroll down on the left, click on the repositories, and there's my Alpine. And if I open it up, I've got one more version, the latest version, that will be specified to the resource for the container image or to fire up our container Azure container instance. So if I go back up here and all resources link upper left hand corner, what I'm going to be interested in looking into the container instances, there it is, my custom cloud container one. If I click to it and open up the properties, I get some overall performance matrix like CPU utilization, memory, network bytes transferred, and things like that. Because remember that there are underlying virtual machines. However, what I can do is start up. If it's not already going to start up, I can go ahead and click start, and when I do that, I'll start all my container resources. Now if I go to containers in here, and I'll see the containers that we have added, that's our custom container, and we have our reference here to the image source. Now let's fire up the second one. So I'm going to go back up here, create resource, and once again containers Azure container instance. I'm going to deploy this to our resource group, and this one is going to be called the caddy web server, and it's going to come down from, let's say, the Docker hub, in this case a public URL. So I'm going to have to specify the name over here. Let's figure out what it's going to be. So here in the Docker hub in my browser, I'll search for Caddy, and here we go. Caddy 2 is a powerful enterprise open source web server with HTTPS and all that good stuff. Now that sounds great. If I click on that, what it is I have to do, I have to Docker pull Caddy. That's pretty simple. Now here in Azure, Docker pool is already implied, so all I have to do is to say, listen, let's get the caddy container image, and it will automatically assume that I'm going to bring down from the Docker hub. All right, I'm going to go and click review and create on our container images based on the public container from the Docker hub, and before you know it, the deployment is complete. So if I click go to resource, we are looking at our caddy web server Azure container instance. I look at the container, here's the caddy, and it's already actually up and running. And if we have to have any log information we want to look at, we'll see any reported log info, such as the fact that it's in our HTTP port 80. Now what's interesting is if I go to the overview here, we have a public IP address. So I wonder what happens if I plug into my web browser. Why don't we find out? As we might expect, because we have a container running on the IP and port 80, that's the default listening port, and we know that there is a web server in that container. It pops up with the default web page, so that's how it's easy how it is to work with container images and get them up and running. In the Microsoft Azure cloud, the only thing to bear in mind is to do the regular things you would normally do to Harden in this case a web server stack and the file system within that underlying web server, which is really in this case all within the application container. Remember that when you want to harden your web server environment and ultimately your web applications, the underlying web server and the operating system, it's running on that host and the hosts on the same network. They all need to be secured. So assuming we have got a web application that runs on Windows platform, perhaps being hosted on Microsoft IIS web server, we have to make sure that we harden the Windows environment. And one way to do this, it's our group policy. So here are many Windows Server. From the start menu, I'm going to type in gpedit MSC to open the group policy editor, but only for this local individual server. So in a little title bar on the left, it says the local group policy editor. If you are a Microsoft person, you'll be aware that if you've gotten a Microsoft Active Directory domain, then you can also configure Microsoft or group policy in the domain. So it's that potentially could have settings that may apply even to a single computer joint on that domain. Here on this individual server, the local group policy editor, the settings I make here will only apply to this individual server, but the settings look and feel the same. You're going to find the bulk of security settings and group policy available under computer configurations on the left. Under computer config, if I were to open Windows settings and then the security settings, it would expose the number of items that will be of interest to us. To harden our web applications or the web server environment, one of the first things is the account policy settings, the password policy. Now this would apply for user account, in this case for this local server. And if we are running a Microsoft web server on this host, we might be using Windows integrated authentication to allow users to log into the website hosted on the machine. So these settings would then apply. So the password history, how many passwords will be remembered, and we don't want other users simply resetting a password to something that they have used previously. We can set the maximum password age, by which then absolutely have to be changed. And then there's this minimum password age. Here it is to set it to 10 days. So when users change their password, it can be something that they have used before, or at least in this case, not at least the last 15 passwords. And then they can even try to change it again for the last 10 days. Minimum password length here is 12 characters. Password complexity requires password requirement enabled. This is all very important in hardening a Windows environment. Same with the account logout policy. And here's I've got 3 invalid login attempts will trigger the account to be locked for 30 minutes. And if I've got the password attacks being perpetuated against the accounts on the host, the account will be locked out. Of course, this means that the attacker will not be able to try numerous passwords to break in. Interestingly, if we were to open this host in the Windows event viewer, so we could view the server logs, and if we go down into the Windows log security, we actually would see that there were any login attempts perhaps that have failed. For example, if I have got an audit failure, then if we kind of drill down and look at what it's trying to tell us, the audit failure will give us the details about date and time, the server on which that occurred. Well, in this case, it's the server that we happen to be sitting at. And what's interesting about this too is that let's just drag it to a bit, and that as I'm going to go down, okay, I see that the username is unknown and a bad password. I even have an IP address from which this occurred. Now that's not an IP address that I know of. This is a virtual machine running in the cloud with the public IP, and so it looks like already someone is discovering that there's a host on the internet with the port 3389 listening, and they're already trying to get in. That's RDP. So if you really wanted to, you could filter the logs. I could right click, filter the logs, and specify which and what it wants to look for in certain event IDs. Now the event ID that gets thrown when we have some kind of audit failure is always the same number. So here it would be 4625. So what I could do is right click on the log, filter the event ID 4625, and then I could press OK. And I'm going to looking at the log on failures. Now, what's interesting about this is that, as I look into these audit failures, I keep looking down. I've got all kind of different addresses. This server is basically potentially being attacked from brute force, from dictionary attacks being done against the account. It happens right away. And so hardening servers, then, which is what we are talking about, group policy is absolutely essential now only if the server is exposed to the internet, but certainly for internal reasons. So back here in the group policy, we can also set a firewall rule for password Windows Defender in the group policy. So inbound and outbound rules, that's the same thing that you could do in the start menu by going into Windows Defender rules. So we could also, if we wanted to, get out of the Windows settings here on the left, but let's instead go under administrator templates and let's go under Windows components. We can even go in things like the BitLocker, drive encryption, and then configure the fixed data drives that we want to allow certain configuration settings for BitLocker, maybe removable drives as well. Now we want to deny write, so I'll enable that. We want people copying data potentially from the file system in this server, and again, if it's a web server, we don't want data exfiltration, we don't want sensitive data leaking off the unauthorized users. We could just configure that by typing things as well. Now, if you're going in a group policy environment within Microsoft Active Directory, bear in mind that when we make changes, it might take a while before they are in effect for computers that should receive those settings. And so from the command line, if I go to my computer, what I would do as an individual host is force group policy to update the firmware if we have an Active Directory environment. So I could run the GP update, force group policy update. So what this is going to do is to talk to the nearest domain controller from which we can pull down the group policy in an Active Directory domain control environment, and we will have a message about computer policy settings and user policy settings being updated successfully. Because if we go and look into the group policy, of course, as we know, it's broken into computer settings, computer configuration, user configuration as well. So not only organizational policies will indicate what kind of configuration settings related to the security that we make here in the group policy. It can be very important to determine any outliers from security baselines. In other words, devices or configurations of web servers or applications do not align with standard security policy, and we can do that in the cloud using Azure Policy. We can assign policies and then we can determine if our devices are compliant, for example, with whatever we determine it's important for security. So to get started, here in the Azure portal in the top center, I'm going to search for the word policy, and then I'll choose policy, which opens up Azure Policy console. The first thing we should do is look at the policy definitions, because there are numerous predefined policy definitions and initiatives. An initiative is just a group of related security policies. For example, if I were to search, like, say, for PCI, and we have a PCI DSS initiative, and I know that this initiative, because it says so under the definition type, and if I click to open up that definition, it shows all the individual policies that are a part of this initiative, like MFA, multi-factor authentication should be a part with the account with owners, permissions, and Azure subscription, and there's a lot of other security items that are listed over here. But the idea is that we can apply this against our resources in Azure to determine if they are or are not compliant, in this case with PCI version 3.2.1 from 2018. Now we can also look at individual policies, and it doesn't have to be a group of them via initiative. So if I were to search, let's say, for the word encrypt, maybe I'm interested in checking that disk encryption is applied on a virtual machine, so maybe that's what I'm primarily interested in. Now these are just definitions. We don't have to look at the policy initiative definitions. You're just going to, at this point of time, this interest is actually work with this. You go to the assignments and you either assign a policy or an initiative. So if I were to choose assign policy, first thing I'm going to do is to determine the scope in Azure hierarchy where I want this to be assigned. Now the default is my subscription. This means that let's say we are going back to the virtual machines having the hard disks encrypted, that would filter down my subscription on every virtual machine, but I could limit the scope by clicking the selector button, and right here it will say that, well, it's fine, but maybe I'll just choose one group in the subscription, let's say Project X. And so in this case, only virtual machines deployed into the resource group would be checked for compliance, and presumably the policy we haven't specified yet, which is to check that the virtual machine disks are encrypted. So we could do that. I'm going to go ahead and select that. We haven't yet selected the policy, and I'll click on the selector to the right of the policy definition. We can just basically search like we did a moment ago. I can let's say for search for encrypt, and let's say disk encryption should be applied on virtual machines. Select, and I'll review it and create it. I'll create the assignment. So what's going to happen then is the assignment will show up, and here's our Project X resource group, but it may take some time for to give us results, because you might have thousands of resources in particular resource group. It has to look thorough, so it might take up to 10 minutes, it might take up an hour, we really don't know, but generally I found about 20 to 30 minutes you'll get some results, and you're going to get the results under the compliance view over on the left. Now I already have the assignment here for checking that disk encryption should be enabled for the entire subscription. Now if we scroll down in the list here for one of our component scope, which is of course the Project S resource group, hasn't even started yet, but up here we have one of the disk encryption should be applied. So same policy, but in this case on the management group, which contains one of the more subscriptions, so at more higher level, currently it says non-compliant, which virtual machines are not compliant. I need to know if I'm going to harden my environment, because they might be running web application code. So I'm going to click to open that up. We'll identify, and sure enough, it's pretty easy to see down below the names of the virtual machines here in the cloud that are non-compliant, within this case having their disks encrypted. So I could click on one of these virtual machines links to open up some details, and even click view resource to go to the actual virtual machine itself. And from here I could then begin to work on disks that solve the problem of encrypting any additional disks that might have been added. So if I click on the disk, we could begin to see all the disks attached to the virtual machine, like the operating system disks and any data disks that deal with any encryption issues. As a matter of fact, in the upper left, we can actually scroll down and launch the Azure Security Center, and which is a centralized place where it shows me a lot of things like recommendation, which can result from policy compliance, or shall we say non-compliance. So I need to enable multi-factor authentication, secure management ports, enable encryption. For data at rest, there's that disk encryption policy. We can click on that one to see the offenders. We really going to go back and going to same type of the thing over there. There's our two virtual machines. While the OWASP top 10 specifically state that software updates might be applied continuously, it does fall under the OWASP top 10 item of security misconfiguration. You could consider not applying patches to the problem at the security level, because a lot of patches will often address security vulnerabilities. So let's talk about then how the patches are managed using Windows Server Side Update Service, otherwise called as WSUS. Now that's a way we can control the internal Windows Update Server that fetches Windows updates from the internet, but then distributes it internally to Windows host under the control. So to get started with what here in Windows Server, I'm going to open the start menu and go to the server manager, because what I need to do is I need to install WSUS components. So what I'll do is I'll click add roles and features, and I'm going to accept the defaults as I go along the way down to the point where I'll get to the list of server roles, because at this bottom the list roles, it's in alphabetical order. I've got Windows Server Update Services. Now if I've got 20 Windows Web Server hosting web apps, I probably don't want each and every one of them going to the internet and getting the updates. They're running on the same version of Windows operating system. That is where we even got the WSUS, means that we can realize efficiencies in downloading those updates, but then distributing them from WSUS host internally to all the hosts that needed. So I'm going to turn to Windows Server Update Services, and I'll pop up and say, would you like to add additional components? I will also like to include admin tools. I do. I'll click on the add features. So I've got added the WSUS role. Click next, and I'm going to continue here, accepting the default settings for WSUS, and there here asks there should we store the updates on this update server. So I'll specify WSUS /updates, and I'll click next, and I'll click install. We are installing WSUS role, but we are going to need to go and configure it in order for us to useful in securing our environment by applying patches in a timely manner. Once the installation is completed, I'll click on close, and I'll click a little alert on the top right hand corner. It tells me that there are some post deployment configuration that needs to be done. For Windows Update Server Services, no problem. I'm going to go to post launch installation task and further configure WSUS. After a moment, the configuration wizard begins. I'm going to click next on the introduction screen, and I'm going to click next on this one. And what we're going to do is sync the updates for Microsoft Server Internet in this WSUS server. We could synchronize from another upstream WSUS server, perhaps one of our headquarters location already downloaded these update server, but in this case sync with Microsoft Update. Next, I don't need to use a proxy server to get out of the internet, so next I'll click on the start connecting button. Make sure that the server can see, in this case, Microsoft Update Service online. So once the wizard has connected and retrieved information about the updates, I can proceed by clicking next. So from here I can specify the languages that I'm interested in downloading for. English is selected. I'm going to click OK. I'm going to click next. So now I can select or deselect any items that I want to look at it in terms of products which would have updates. So for example, if I know I'm going to be using a certain subset of these components, I'm going to go ahead and select whichever item I want to get a list of updates for. So for instance, maybe I'll select just something quick here, Windows 10 latest drivers. I know I'm going to be using that internally. I'll click next. Maybe I just want the security updates, so I want driver sets. I can choose the classifications of those updates. I'll choose next. I can sync manually or specify how many times per day. I'll leave it on and manual for now. I'll tell it to begin the initial sync. I'll click next, and I'll go ahead and I'll click finish. Now after that is done, you can go to other options here in the WSUS management tool. Make sure that the changes, perhaps the products or classifications that you are interested in getting the updates for. So you can now come back here and change your mind at any point of time. So for example, if I've specified sync, I've got the list of sync over here, and of course I click on write and synchronize whenever I wish based on my settings. What I'll end up getting here is a number of updates, so I'll go security updates. So here, let's say if I look at my status of any refresh, I've got the number of Windows Server 2019 types, updates, and so on. Now for computers, over on the left, I could build a computer group. I could right click and add a computer group called IIS web service, because maybe that's what we want to control and patching for hardening our web application environment. We could configure a group policy to determine servers in Active Directory. Let's say that we should become a member of IIS web service group, or we could go into the unassigned computers built in the group and just simply move them over there. Whatever the case might be, to determine which computers will be affected. But what I go look at my security updates, I can go to any one of them or select group of them. I can right click on choose approve, and this is where I could go and deploy to a specific computer group. So if I click, for example, on the arrow IIS web servers, I could choose the approve for install, and then I could choose OK. So whichever servers are then a member of our group, so that would be over here on the left. And of course, the IIS web server group would receive those updates internally. Mitigating security misconfigurations is actually a tall order because it means so many different things. Now, mitigating these type of problems means proper planning right from the beginning, and so we don't end up having security misconfigurations such as non-complex passwords or a device or may be the default installation directory for our web server left as it is, so we can use baselines of security settings that are acceptable for hardening our organization. And we can compare that against our configurations in our production, so against the web servers, to make sure they are configured in a certain manner. And then we easily identify them misconfigurations that are non-compliant and focus our attention on them, bring them in compliance to enhance our security posture of the organization. Now, this also means that we have an inventory of out there on the network, because otherwise we can compare security baselines to something if we don't know that something is there and doesn't meet our security requirements. You need to have to be up to date with the inventory of everything on the network, which means that they should be conducted periodically. Personally, I'll recommend that this is done daily. It's an automated daily scheduled task using the tool of our choice to scan the network looking for devices. Now, web application firewalls are designed to look for specific web application traffic attacks that they could prevent and report the potential web application violations but really, when we talk about security misconfiguration, let's say that applies to file system permissions on a Linux-based container running a web server. Well, our web application firewall honestly is not going to pick up on those types of security misconfiguration. It might pick up some basic ones at the web application level, such as lack of input validation, which might allow the cross-site scripting, but always be aware of the scope that web application firewall is configured to look at what it can do, because it can't do everything. The next thing to think of how to identify non-compliant configuration using specific tools. The screenshot comes from the Microsoft Azure Policy, where we can do this. We can assign policies to our Azure hierarchy, such as to the entire subscription, perhaps looking for PCI DSS compliance, or to have secure environment when working with sensitive cardholder information, or requiring disk encryption on virtual machines. We can very easily look in at these GUI reports that are on the far right under compliance state. Some of these policy assignments are compliant, others are not. Naturally, we need to focus on the non-compliant states because we need to identify offending configurations so that we can focus our energy on them to bring them into security compliance. So specific things might you consider in mitigating security misconfiguration might be to make sure that you're using different admin credential set for all of your system. So for network infrastructure devices, for virtual machines, for cloud accounts, you don't want to use some admin credentials, because naturally of those credentials are compromised. It's a kind of like having the keys to the kingdom. Now, standard hardening techniques come into play all here, such as disabling unused services. This is essentially important for web server stacks that might have modules embedded like for Python you don't need because you're not running Python scripts, or they might have support for SSL, which you don't want because you're using TLS 1.2. Other standard things we can do to make sure that unless absolutely required, we are not exposing any web applications on server directly to the internet, because if we are, you can kind of think of it being a sacrificial lamb. You know that at some point it's going to be scanned and people are going to attack it, and if you are not secure properly, it could actually become compromised. So we want to be very careful with, certainly with public facing websites, we don't have a choice, but there's where the web application firewalls are adhering to all those security hardening techniques is especially critical. Other security misconfigurations, the lack of network encryption. Here you've got a packet capture of Wireshark, where we got some FTP traffic that's not being protected as it might be, perhaps by using FTPS or by using an IPsec, or maybe using an encryption tunnel, VPN tunnel. None of that has been done here, because we can see that the FTP traffic is clear text, where the username is administrator and the password is a variation of APC123. It's almost too easy. So if you're going to using an encrypted solution that is simply not accessible with a simple packet capture, ideally, because security technicians are already so busy with day-to-day, we would have to have an automated solution in place on a scheduled basis that will conduct a configuration review. Now, maybe that comes in the form of using security baseline comparison against what's out there on the network so we can identify non-compliant configurations. It might also include periodic file system reviews to see who has full permission on the file system where they might legitimately need it, or it might have been granted in the past but is no longer required. But unless we have these kind of periodic reviews, how will we ever find out about those security misconfigurations? So in this course, we've examined how to detect security misconfigurations and how to deploy solutions to remediate these weaknesses. We did this by exploring security misconfiguration attacks. We examined application containers and how to manage containers using Docker. We also looked at how to create and populate a container registry with container images and how to deploy a cloud-based HTTP container. We then examined how to harden security settings using Microsoft Group Policy, and we configure Azure Policy for security compliance. Next, we managed patches with Windows Server Update services, and we also managed virtual machine patches in the Microsoft Azure cloud. And finally, we examined how to mitigate security misconfiguration. Hope you like this video.